Hello, my name is Robyn Price, and this is my energy presentation. Today I'd like to discuss two types of energy, nuclear energy and solar energy. Nuclear power is ultimately not that different from the energy that we get from coal. Dig up a finite resource and apply energy in a very specific way to unleash a much greater amount of energy stored within that fuel. For coal, we apply a small amount of heat to release energy within its chemical bonds. For nuclear energy, we apply radiation to release the energy stored in uranium's bonds. To get a lifetime supply from coal, the average American would have to create tens of tons of solid and airborne waste. The same figure for nuclear reactors sits at about 5 kilograms of spent nuclear fuel per person. Although nuclear energy is considered clean energy, its inclusion in the renewable energy list is still a subject of debate because the supply of uranium is not infinite. Renewable energy is defined as an energy source or fuel type that can regenerate and replenish itself indefinitely. The 5 renewable resources that we're most common with are biomass, wind, solar, hydro, and geothermal. Nuclear energy, on the other hand, is a result of heat generated through fission. Nuclear power is generated in a nuclear power plant where uranium atoms are split inside of the nuclear reactor. When an atom is split, it produces a chain reaction. Energy flies out of one split atom and hits the other, and so on and so on. All power plants convert heat into electricity using steam. At nuclear power plants, the heat to make the steam is created when these atoms are split, again called fission. The fission releases energy in the form of heat and neutrons. The released neutrons then go on to hit another neutron and repeat the process over and over, hence generating more heat. In most cases, again, the fuel used for nuclear fission is uranium. Today, only 8 countries are known to have nuclear weapons. In high contrast, 56 countries throughout the world operate about 240 nuclear reactors. 16 of these countries depend on nuclear power for at least 1/4 of their electricity. With the rapid development of nuclear energy and the probability of a nuclear power accident, although it may be small, the human and environmental consequences of a radiation release can be catastrophic. Next, I'd like to talk about solar power. Solar power is generated using solar panels to collect the sun's rays. When the sun shines on them, they turn the rays to energy, and solar energy is a renewable energy, which means there is no limit or end to this source. Simply put, a solar panel works by allowing photons or particles of light to knock electrons free from atoms, generating a flow of electricity. Solar panels actually comprise many smaller units called photovoltaic cells. Many cells linked together make up a solar panel. Each photovoltaic cell is basically a sandwich made up of 2 slices of semiconducting material, usually silicon. A more detailed explanation of how solar power is generated is that after the sun rays are captured, when light hits your roof's solar panels, the panel actually converts these photons into electrons of direct current, or DC. Those produced electrons flow from the panel into an inverter. The inverter converts that DC power into an AC, which is the kind of electricity that we use, or alternating current. The biodirectional meter keeps track of all the power that is generated in the solar panels, and any energy that's not used will go right back to the grid or the meter. The most significant similarities between nuclear and solar energy is that they are both pollution-free and have no direct emission of carbon dioxide or other greenhouse gases. Both nuclear and solar energy give a carbon dioxide savings of about 1,330 kilograms for every 1 kilowatt electric power used per year. Even though they do provide a very small indirect emission of gases, the quantity of pollutants in both of them is small and very minute. However, the price of low emission and the improvement of efficiency is expensive and difficult for both, so it may be another decade or 2 before we're using these 2 energy sources exclusively for the betterment of our environment and the quality of our lives.